All right, everyone, let's talk about a chapter where most students make mistakes. But listen, if you really get this chapter right, you can pretty much lock in 2 to 3 questions on your JEE exam. So today, we're going to make everything crystal clear. Yep, you heard that right. Motion in a plane is seriously one of the most high-scoring topics out there. It doesn't matter if it's mains or advanced, you are guaranteed to see questions from this section. So let's make sure that after we're done here, you can tackle any problem from this chapter with total confidence. Okay, so let's dive right into our first big topic, projectile motion. Now, I know it can look kind of complicated when you first see it, but trust me, there is a very, very simple secret to it. Think of it like a master key that unlocks every single problem you'll ever face. And here it is. This slide right here, it basically captures the entire chapter in one single idea. This is the master key. All you have to do is treat any 2D motion as 2 completely separate, super easy 1D motions, one happening in the horizontal direction and the other happening in the vertical direction. That's the secret.
And this slide just shows that idea perfectly. I want you to think of them as 2 completely separate worlds. First, you've got the horizontal world, along the x-axis. In this world, there is 0 acceleration, which means the velocity is always constant. It never changes. Then you have the vertical world, along the y-axis. Here, the only thing acting is gravity, so the acceleration is constant. Ay equals minus g. That's literally it. So here's the most crucial point. The very first step in any projectile problem is always the same. You take the initial velocity, u, and you immediately break it down into its components. The x component is u cos theta, and the y component is u sine theta. And just like that, you now have 2 simple 1D problems to solve instead of one complex 2D problem. Okay, so now that we have this master key, let's see how it actually helps us. We're going to use this one idea to derive all the important formulas and even look at some common tricks you see in previous year questions. And remember, the goal here is not to just memorize things, it's to understand where they come from. First up, time of flight. So what is it? It's just the total time the object stays up in the air. Now think about it. This is purely a question of vertical motion, isn't it? The object goes up and then it comes back down. How long that takes has absolutely nothing to do with how fast it's moving forward. The formula comes directly from our good old equations of motion, just for the y-axis, and it's the exact same concept for maximum height. When does the object reach its highest point? Well, it happens at that one specific moment its vertical velocity, Vy, becomes 0. It stops going up for an instant before it starts coming down. See? Again, this is just a simple 1D motion problem only happening on the y-axis. And now we get to range. This is the cool part. This is where our 2 separate worlds finally meet. So what is range? It's the total horizontal distance the object covers. So how do we figure that out? It's incredibly simple. You just take the constant horizontal velocity and multiply it by the total time it was in the air, the time of flight. See how it all connects? Okay, time for a classic exam-style question. Imagine you have a ball, and I tell you that you can throw it at a fixed speed, but you can choose any angle you want. What angle would you pick to make that ball go the farthest, to get the absolute maximum range? All right, let's really walk through the thought process here. We're not just memorizing the answer. So step 1, write down the formula for range. We want to make r as big as possible. Now, since u and g are just constants, the only thing we can change is the sine of 2 theta part. So to maximize r, we have to maximize sine of 2 theta. What's the biggest value a sine function can ever be? It's 1, right? So we just set sine 2 theta equal to 1. And that means 2 theta must be 90 degrees, which gives us our final answer, theta equals 45 degrees. And we're done. And here is a super useful JEE trick that will save you a ton of time. For the exact same initial speed, the range is always identical for complementary angles. What does that mean? It means the range if you throw it at 30 degrees is exactly the same as if you throw it at 60 degrees. The range for 20 degrees is the same as for 70 degrees. Keep that in your back pocket. All right, that's projectile motion done and dusted. Now let's move on to the second superstar of this chapter, relative motion. This whole topic is basically a game of perspective. The motion you see completely changes depending on where you're looking from. The key to this entire topic, it's all in this one single formula. The velocity of A with respect to B, which really just means what an observer sitting on B would see is simply VA minus VB. But you have to remember one absolutely critical thing. This is vector subtraction. Direction is everything here.
And the most famous example of this is, of course, the Rain Man problem. You've got rain falling straight down and a person running forward. So from the runner's point of view, what does the rain's motion actually look like? At what angle do they need to hold their umbrella to stay dry?
Let's solve a real problem with some numbers. A person is running forward at 4 meters per second. At the same time, rain is falling straight down, also at 4 meters per second. So, to stay perfectly dry, at what angle from the vertical should they tilt their umbrella?
Let's solve this thing from scratch, step by step. Okay, step 1, define the vectors. The rain is falling down, so we'll call V rain minus 4j. The man is moving to the right, so V man is 4I. Step 2, we need the velocity of the rain with respect to the man. That's V rain minus V man, so we get minus 4j minus 4I. Step 3, now we just find the angle of this new vector. Tan of theta is just the magnitude of the vertical component divided by the horizontal component. So tan of theta equals the magnitude of minus 4 divided by minus 4, which is just 1. And when is tan of theta equal to 1? When theta is 45 degrees. See, it's that simple. Now, another really important case for relative motion is the riverboat problems. And for these, honestly, you just need to remember 2 shortcuts. If you want to cross the river in the shortest possible time, you have to point your boat perfectly perpendicular to the river's flow. But if you want to travel the shortest path, meaning you want to land directly opposite to where you started, then you need to aim your boat slightly upstream to fight the current.
Okay, wow, that was a lot, but you guys did great. Now it's time for a final revision boost. This is your cheat sheet with all the most important points right here in one place.
So, let's do a super quick recap. What's the secret to 2D motion? You break it into 2 1D motions. For the x-axis, acceleration is 0, velocity is constant. For the y-axis, acceleration is minus g. At the highest point, what happens? The vertical velocity is 0. Range is maximum at 45 degrees. And relative velocity, VAB, is just VA minus VB. That's pretty much the whole chapter. And remember, this chapter is the foundation of mechanics. Seriously, if this chapter is strong for you, the rest of your physics preparation will feel so much stronger. Master these concepts, practice a lot of problems, and I promise, you will absolutely nail it in your exam. Keep up the amazing work.